Okay, hello everyone. This session we'll be talking about the correlation and regression from our lecture 4. So we'll try to understand what correlation really is, what regression really is, and then we'll take it from there. Okay. But then in this our correlation, we are going to be making use of only two variables. Okay, so we are going to have something like, let's say, some x and y. Let's just say we are going to work with that. So we're not going to work with maybe three variables x, y, z, and then the fancy name for it is bivariate, right? Bivariate, right? Okay. So let's start with correlation. So what is correlation? So correlation is simply a number that shows this how strongly related two variables are from a particular data. So you have a data, you've been able to not necessarily plot maybe some. So for instance, let's say if you're able to plot a straight line through them, right? And then your correlation, okay, so your correlation can become like, it depends, but then you can get like, if everything goes through the line, then you can get something like maybe 1 or something. Yeah, so that would be like 4, 1. So if you can get a gradient, constant gradient, that would be like 1. And then if it is not like one line, but then let's say you have a number of points, and then it forms like some scatter plot. So the points are distributed inside to the extent that you cannot draw one line through everything. Then that's where correlation becomes useful. So you can actually determine the strength of the correlation, right? Yes. Okay, that's the strength of the correlation. I mean, strength of the relationship between the variables. Okay. Okay, so we are trying to always find some direction, some form, strength, degree of linearity. Yeah. So I'll explain this as we move on. Okay. So generally, we know what scatter plots are, right? A scatter plot. So, so you have some set of information, have some x. This is not the right way of writing things. Right? So we have some y, we have some x. Okay. Then we plot everything we have. So we have some bivariate data. Then we plot it to look like something like this. So what correlation does is we try to find if you have these points, how strongly related are the points? Yeah, how strongly related are the points? So maybe we can let's just use a practical example. So let's say we want to we have maybe the height of people and their weight. Okay, so you can plot their height here, maybe their weight here. Then we see, okay, is height really related to weight? So is height really related to it? I'm trying to find. So if you have someone of this height, what weight should we be expecting? Is it really related? So what should we be expecting falls under regression? But then is it really related? Falls under correlation. I hope you get the difference. Yeah. So if you work correlation, you're always looking for one number, right? And it's called the coefficient of linear correlation. So like I said, we are going to be using two variables. So we'll call it the coefficient of linear correlation, or basically the coefficient of correlation, or linear correlation coefficients. It has many names, but then it's still the same thing. It has this formula. It follows a pattern, so you can actually memorize it if you want to. But then he said he will give it to us during the exam. So and then you have to pay attention to the variables, how they are working, because it's not okay. I'm now writing out of this one, but then anyway. Okay, so we find that it looks like this. So you have the product, right, times the number summation of each. then so this one is just like some identical form of this and the y. Okay. Okay, so let's just look at some properties of R. So what are the properties of the correlation coefficient? It's always between -1, right? So it can either be equal to, right, 1. So unlike probability, this one is always between -1 and 1. Oh yes, so that's just it. Now you can one interesting thing about this one is that if you have weight here, you have, so in our example here, okay, so let me draw another one. You have weight, and then you have what, weighted height. Okay, now if you find a correlation for this, you find R for this, you get some number. So let's say we got R to be 0.7. Okay, so that means that there's some correlation between weight and then height. If you switch this, so if you bring height here and you bring weight here, you'll still get the same number. If I multiply height, so let's say times 10 power -2 times 10 power 3. So maybe I'll be looking for, if it's weight here, then I'll be looking for some kilograms, or maybe the weight was in grams, so some kilograms. Height maybe some centimeters. Okay, you still get the same number. So if you multiply by any scalar or a scale, right, you still get the same number. Okay, so basically what does it do? It measures the strength. So regardless of what you are doing, it will remain the same, fairly the same number. Okay, so now that we've established that, so why is this side negative and this side positive? So if it's negative, then you're talking about what? A negative relationship. Positive relationship. As direct as that. So positive would mean a direct relationship, negative would mean inverse or indirect relationship. And then with the values, right, you have some ranges, right? So let's just briefly go through this. This is quite direct. So let me just try this down. Okay. So if you have probability at 0, then there's 0 correlation. If you have 1, there's perfect correlation. But then if you have anything in between, so this can be some weak correlation, intermediate or moderate, and then you have strong correlation. Now what happens if you have R equals 0.25? What is it, weak or it is moderate? Yes, it's moderate. So always pay attention to these things, right? They are really important, so just pay attention to them. Okay, so that's just it. We'll move on to, so there are some correlation diagrams and then their value, their linear correlation coefficient values. Okay, so that's just it. That's just it for this one. So let's say we have an example, right? Okay, let's try and pick a very lazy person's example. Let me just pick a very simple example, then let's solve. Hopefully we finish this one early. Okay, so so from here, so let's say we have maybe height, weight. Okay, let's give some to the weight. This is fine, and then the weight, let's say 4, 5, 6. Okay, so that will mean that this will be your, okay, let me just use x and y so that we don't get confused at any point. Okay. So x and y. Now from the formula, what do you need? So first you need your xy, right? So you need your xy, then you multiply, so you just get 4, 10, 18. Okay, and then but then you need a summation of that. So what will be a summation of this? Right, so if you just add this one, you should be getting something like 32. Then you're done with this one. And then summation of x, you need some summation of x. So just be checking the formula to write down the things you need. So summation of SENG is 6, summation of the SENG is 15. Okay, and now you need x squared, right? Now how do you get s squared? So s squared, so you just get 1, 4, 9. Then you can add these and you get 14. And then y squared, alright, y squared, what do? You get 16, 25, 36. Okay, this now look like a lot. So, but then how do you, so you just write down the total. Okay, so this give us like, where's my calculator? So this give us 77, right? Yeah. Let me confirm. Or is it 87? Okay. Looks like I'm okay. So 77. Okay. So that's 77. Now we are done with this one. Now we want to find R. What is our R? Okay. We're trying to find R. Basically, we have everything we need. Okay. So here, let's come to the formula. So if we come to the formula, we need n. So n is 3, obviously. So you need n summation xy. So let's write them here. So n summation xy. So what's our xy? That's 32, right? At 32. So 3 times 32. So say r is equal to 3 times 32. And then we have minus summation x summation y. So that's this times this minus 6 times 15. All divided by, I don't know what number we'll be getting, but anyway, we'll get something. All divided by square root of, so we have n times summation x squared. So that's 14. So 3 times 14 minus summation of x squared. That's different. That's this one. So that's 36. And then we multiply this one by the square root of n times summation of y. So y squared. So this one, 77. So n times 77. That's what? So that's 3 times 77. Okay. 3 times 77. Minus, what's our, so that's of summation y squared, right? Summation y squared is 15 squared. That's 15 squared. Or that's 225 anyway. So with this one, let's just so to save us time, I'll just type into the calculator that we go. So 3 times 32 minus 6 times 15, all divided by, okay, all divided by, so let's just say 42, and that's 6, sorry. Square root of 6 times the square root of 3 times 77. I don't want to bother myself. Okay, so we get some number which is 0.1706. Okay, so now, yes, so we've calculated our correlation coefficient, and this is giving us this number, which means that there's really very low correlation between the two values, which makes sense because I just wrote 1, 2, 3, 4, 5, 6. Now you can't, it's difficult to like find an equation that works for these, or yeah, it will be difficult to find one because this one will be times 2, but then this one is not, and this one is something different. So maybe yeah, maybe some y is equal to what. Okay, so I'll just leave that. So maybe okay, 3 plus x. Okay, I think this is this close. Well, let's leave it. Oh yeah, that's correct. I think this is correct. This is the equation that describes this. So though you can find an equation that describes it, it's something else, right? But so there's still low correlation. Okay, so let's move on. Now we get to regression. Right, regression. Now, in regression, what are we trying to do? We are trying to find an equation. So correlation is trying to find a coefficient, a number, and regression is trying to find what? Regression is trying to find an equation. Okay. Line of best fit. We know what that is. The line of best fit formula is basically a straight line, right? Okay. Now, if you remember from our numerical methods, we did least square regression. That was really interesting. So we had something like y cap was b1x plus b naught, and you could go on and on and on, and this was it. And then our error was, so let's say you have some function, our error will simply be there. We did this, right? Is similar. So let's say we have this, and then the real thing is supposed to be y, then you get y minus y cap. You can switch it, it's still the same thing, just that it will be the negative of that error. Okay, and then if you want the least square, then your error squared will now make switching it of no use. Okay, so whether you switch it or you don't switch it, it doesn't have any effects now. Okay, and then so you remember when we're doing numerical methods, we're always trying to find a b1 and b naught, right? And then we're using some long formulas, right? Or maybe you could use the table. That also worked very perfectly. But then in this statistics for engineers, let's focus on the methods we are given. Okay, let's focus on what we are given. Okay, there's some example in the slide too that also shows potential should I say potential malfunctions of this whole method too. So I think they drew some graph 1 2 sorry like 1 2.12 2 4 3 1.5 and then 4 3.2, and then the question was, where would you put the line of best fit? So will you put it this way, right? So let me just so let's say if you put a line this way, right? How about putting the line this way? Because you find that it does the work. So look at something, you find that at least, okay, if I position this one better, it's a good approximation. This is also a good approximation. This is a good approximation. So the question is, where do you decide to pick which one, right? Okay. But then these things all have their formulas, so we won't just go much into all of that. Let's just go to calculating our b naught and our b1, since that's what probably that's what you signed up for. Okay, so we have summation y, summation of x squared minus summation of x, summation of xy, all divided by n times summation of x squared minus summation of x squared. Okay, different stuff again. And our b1 is equal to n times summation of so a summation of xy minus summation of what, x, and then times summation of y, and all divided by our n times summation of x squared minus summation of x squared. Okay, so this is how you solve it, right? But then let's say we just want to be just a little lazy. Let's use this one. So let's use the example we just solved to make things easier, just for understanding too. So if we want to find our b naught for this will be what? So we said summation of y, right? So that's the summation of y we calculated, that's 15 times summation of x squared. So summation of x squared, so the x squared, that will be 14, and then we subtract summation of x, so also summation of x, that was 6, times the summation of xy, which was 32. Then you divide, by your n, which was 3 times summation of what? Summation of x squared. So that's just it. So summation of the x squared. Where is it? Your x squared, right? Which is 14. Then you subtract your summation of x squared, just 36. This one squared. So basically that is just how you go about stuff like this. And the thing is that b can be any number, right? It doesn't have to be positive. That's that. Yeah, it can be any number at all. Actually, it can even be 0. So this is 3. So our b naught is equal to 3. Okay. So which makes some small sense. And our b1. So to calculate our b1, we take our n times summation xy. So our n times summation xy. Where is it? N times summation xy. So our n is 3. Okay. 3 times xy. We did xy here, which was 32. And then minus our summation of x, which is 6 times summation of y, right? All divided by the summation of x squared, which was the summation of x squared, so that will be 36, but then times n, so times 3, minus summation of x. Okay, sorry, I made a mistake. So this was not summation of x squared, this is summation of x squared, that's this one. And then minus summation of x squared. These are different stuff. So let me just type this until then we see what we have. So 3 times 32, okay, minus 6 times 15, all on 3 times 14 minus 36. So this gives us 1. Right? Our b1 is equal to 1. Now we have everything set. Now we have to write our final equation. b0 plus b1x, right? So y is equal to 3 plus 1x, which is x, okay? So you don't write 1x. So basically that's just it. And then, so if you can just look at it and write, so remember what I wrote down earlier? That was y equals 3 plus x. So you can just look at it and write down the equation. You don't have to go through all of this long process to just get what you can look at, right? So yeah, but then obviously if you can give us examples that are easy, you can just look at it and see that this is the equation. So yeah, so that's just it. But then there are some few things which, so basically that's everything about correlation and regression. That's how to solve it, as much as this lecture is concerned. But then there are times you can use other formulas, like he showed in class. You could use those formulas to calculate it as well. But well, just to make things easier, it's not necessary. So if you have the formula for x, you have the formula for b naught, you have the formula for b1, and just put them inside and calculate. The thing is that you would have some degree of errors, right? You will have some degree of errors in your calculation, which is fine. You have some degree of errors. So let's say in the example he gave us about what, some supermodels and their weight and height. Yeah, it's something similar. Okay. So that's just it. And then so with this one, right? Then they can ask you that, okay, so if I have a number that is say 10, what will be the y? Then just say y is 13. So that's all you're trying to do in regression. You're trying to okay, but there's something you should take note of. I didn't mention this. Now with this one, you realize that this one is greater than everything we had here, right? Let me mention this one quick before. So this one is not always correct, right? What I just did is not always correct. Yeah, so it's not always correct. So here, you have your range being from 1 to 3. Now in some cases, if you are picking, so let's say you're trying to find x at x equals maybe say 15, right? Now you find that 15 is not in the list. So if 15 is not in the list, what do? Sometimes the convention is that you pick the highest number. So you can just say x their s approximate y will be something related to what 6. Yeah, this is one of the things that we're complaining much about in the class. Or if they ask you to find x, x at maybe say 0.1, you find that 0.1 is not in the decimal. So what do? You sometimes assign it the least value, which is y equals what 4. Now, but you might want to do like so if they give you a number that's in the range like 2.5, then you can boldly put it inside. So you can say y is equal to 5.5. Now, some of the things have constraints, right? So for instance, let's say you're working with a population. If you're working a population, then it's quite different than just doing a normal calculation, because you're using population, and then let's say there were heights, right? Some of the numbers will be unrealistic. That's just it. So assuming they give you the height of someone to be maybe 6 feet, and then they ask you to calculate the weight, and then from your correlation formula you have the weight to be like 300 kg. It's not the usual. It doesn't make so much sense. Yeah. So that's just it for this regression and correlation. Yeah. So basically that's all for now. And thank you for watching. And if you have any concerns, as usual, you can put them in the comments in the groups, and then we'll discuss it. Thank you.